Hi folks, this is Calc 2, Checkpoint Quiz 1. Number 1, we're asked to state the integral definition of the function natural log x. So as we saw in class, we define the natural log x to fill the hole left by the power rule we had from Calc 1. So the natural log of x is defined to be the integral from 1 to x, 1 over t dt, and this is good for x bigger than 0. So in addition to having the integral, we also need to know the domain here. And so that's it for number 1. Okay, number 2, we're asked to find the following limits. And the limits that are of interest to us that we know from class is if we take the limit as u goes to 0 from the right of the natural log of u, this is minus infinity, and the limit as u goes off to infinity of the natural log of u is infinity. So we had these from class last time, and so we put these to good use here in this problem. Part A, we're asked to find the limit as x goes to 3 from the left of 2x minus the natural log of 3 minus x. So if I look at what's happening inside that log, I can think of that 3 minus x as being what's inside the log. That's like the u. And as x goes to 3 from the left, I'm thinking mentally of plugging in values like 2.9, 2.99, 2.999. 3 minus something a little bit less than 3 is something that's very small and positive. So the inside of that log is going to 0 from the right-hand side. And so this first limit tells me that this term is going off to negative infinity. What's happening to this term? Well, as x goes to 3 from the left, we know from Calc 1, 2x is just going to go to 6. And so we have 6 minus negative infinity. And so that limit then, we have 6 minus unimaginably large negative numbers, gives us an unimaginably large positive number. And so our final answer then is infinity. Okay, in part B, we're asked to find the limit as x goes off to infinity of the natural log of 3x squared minus 5 over 3x squared plus 2x plus 1. So to figure out what's going on here, we need to look inside the logarithm again and think back to Calc 1. As x traipses off to infinity, what's happening to this ratio? Well, the degree of the numerator is 2, and so the leading term here, the term that's going to matter as x goes to infinity, is 3x squared. That's the same as the leading term and degree of the denominator. So as x goes off to infinity, these are the terms that matters, and the limit is the ratio of these terms. So this is going to 3x squared over 3x squared, which is just 1. So the inside of the logarithm is heading towards 1. Since the natural log is continuous, I know then that the limit as x goes to infinity of this is going to be the natural log of 1. And we know from algebra the natural log of 1 is 0. So that'll do it for part B. All right, in part C, we've got some trigonometry going on. We're looking at the limit as x goes to pi over 2 from the left of the natural log of the tangent of x. And so, just as before, we have to look at what's happening inside that logarithm. And as x goes to pi over 2 from the left, if we think back to the unit circle here, x is approaching pi over 2 from the left. So we're thinking the angles are heading up towards the positive y-axis. Well, the tangent, which is sine over cosine, is becoming larger and larger and larger. Actually, it's heading off to positive infinity. So if I think of this as what's inside u, this is actually going to infinity. And so we know from this property that as the inside of the natural log goes to infinity, the natural log will take that value also to infinity, although markedly slowly, more slowly. And so that'll do it then for number 2.